Every incremental load begins with one dangerous question: new since when? Set the boundary too old, and yesterday's rows return for an encore. Too new, and real changes vanish. Neither is fun to explain on Monday morning. Data Culina treats that boundary as part of the ingestion contract. In this episode, we'll follow the watermark gate and see how full and delta loads share one controlled route without pretending they are the same job. The framework supports two ingestion promises. Full says, give me the complete current state. Delta says, give me reliable new or changed rows. Full fits sources without trustworthy change boundaries in cases where complete state comparison matters. Delta fits sources with a dependable change column and incremental access. Same framework, different promise. Think floodgate versus turnstile. One admits the whole crowd, the other admits arrivals beyond a known line. Delta without a defensible boundary is just optimism wearing a timestamp. For Delta, Data Culina resolves that boundary from evidence in staging. It inspects the configured source delta column in metadata, and takes its maximum value. That maximum becomes the watermark for the next extract. There is no separate control plane dial moving itself forward. If staging does not exist, is empty, or yields no maximum, the framework uses the configured fallback watermark. That gives the first run an explicit starting point instead of asking the pipeline to improvise. A watermark is not a decorative date, it is the lower edge of the next extraction window. Once resolved, the connector translates the watermark. An API can map it into its configured delta parameter. A database query receives a predicate, source delta column greater than the resolved watermark. For file sources, Spark applies a configured row filter. Important asterisk: filtering rows inside files does not discover only newly arrived physical files. The path, partition, or upstream file movement must still bound what Spark reads. The contract stays consistent while connector behavior remains honest. Platform agnostic does not mean every source speaks with the same accent. Both promises follow the same route. The source is captured in landing. A copy branches to archive for preservation. Landing then moves through the delta storage layer, where records are standardized and flattened before staging receives an append. Yes, delta appears twice because naming enjoys mischief. Delta ingestion mode means selecting new or changed source rows. The delta layer is a processing stage used by both full and delta loads. Same word, different job. Keeping them separate prevents a load strategy from being confused with a storage layer. Now open the full gate. A full run brings the current source snapshot through the route and appends it to staging. It does not overwrite staging. Retention then keeps the latest 7 load date copies. 7 copies, not 7 days, a small distinction with large consequences for weekly schedules. Those snapshots support complete state comparison, deletion detection, and dimension processing. Full is heavier, but sometimes the complete view is the feature. If the source cannot promise reliable deltas, pretending otherwise only makes the pipeline lighter on paper. Now turn the gate to delta. Only rows beyond the resolved watermark pass the connector filter, and those records append to staging. Existing rows remain. On the next run, the framework again takes the maximum source delta value in staging and resolves the next boundary. The loop is evidence-driven. Read the boundary, extract beyond it, append, then derive again. No ceremonial, watermark advanced message is needed. The loaded data supplies the next checkpoint. Before staging feeds integration, the framework deduplicates the selected records. Then keep 2 levers separate. Ingestion mode, full or delta, decides which source records enter. Target write mode decides how a target is applied. Truncate and insert, append, upsert, or SCD2. One lever chooses the input window, the other chooses write behavior. Integration can remain transient and rebuildable while its staging input is selected incrementally. Required transformation tests must pass before success. Same machinery, clearly separated responsibilities. Choose deliberately. Use delta when the source exposes trustworthy incremental change. Use full when delta support is missing or unreliable, when complete state comparison or deletion detection matters, or when conservative recovery is safer than clever backfill. The watermark gate is not about moving less data at any cost. It makes every boundary explainable. Next, we'll see how SCD2 turns controlled inputs into history, with hashes, effective dates, current flags, and tombstones. Explore the framework at datacalina.com.